Identifying direct variations. In order to talk about lines, we need to remember that they all have slopes, where the slope is the vertical change divided by the horizontal change, or the change in the dependent variable with respect to the change in the independent variable. Rise over run, rate of change, constant of variation, they all mean the same thing. Remember, rise is like the sun, it goes up and down, and run is like a sprinter that run across left and right. All of these linear relations represent direct variations. Look at the graphs, look at each line, look at the red line. If I look at the red line, I see that I go right 1, up 2 to go to a point. I can go right 1, up 2 to find another point. If I look at the orange one, I can go up 2, left 1 to go to a point. Up 2, left 1 to go to another point. The y values continually increase by 2 as the x value increases by 1 on the red line. On the orange line, as the x values decrease by 1, the y increases by 2. How could I get the y value from an x value if I look at those graphs? For the red one, x is 1, y is 2. So I've got the point 1, 2. And I've got the point 2, 4. What happens to the x to get the y? Take a minute and think about that. The y value is found by doubling the x value or multiplying by 2. If I look at the orange line and I look at the ordered pairs x and y, when x is negative 1, y is positive 2. When x is negative 2, y is positive 4. So instead of multiplying by 2 this time, we multiplied by negative 2. If I look at this bluey gray line, when x increased by 2, y only increased by 1. So if I look at the blue line, I've got x is 2, y is 1. If I increase my x by 2 again, my y increases for a total increase of 2. So x is 4 right here, and y is 2. Every time I change ordered pairs here, in the red line, I doubled my x value to get my y, or I multiplied by 2. If I look at the orange line, the x value was multiplied by negative 2 to get the y value. When I look at this bluey gray color line, the x values were multiplied by half. Does something similar happen to the other lines? Take a minute and look for patterns. Pause the video and look for them. If you took the time to pause the video and look, you would see that in all of the lines, the y value is found by multiplying the x coordinate by a constant. The other thing you should notice for all of these lines is they all pass through the origin. That leads us to the definition of a direct variation. Direct variations are relationships that can be represented by a straight line through the origin. That is, the y-intercept is 0. And remember, the y-intercept is the point where the relation crosses the y-axis. Remember this axis right here. That's your y-axis. Relationships such that the pattern shows one variable is determined by multiplying a second variable by a constant is another way of describing a direct variation. Finally, relationships where the pattern can be expressed as the value equals a constant or a number multiplied by the position number is a way of describing a direct variation. Now, the value in these cases would be the y value. The position number in this situation would be the x coordinate. And your number would actually be, or your constant that you're multiplying by. If you look back here, if I look at this red line, I went up 2 over 1, and that's actually my slope, positive 2 over positive 1. And that's what I multiplied by. So if I look at this, y equals mx is the equation of a direct variation where m is the slope of the line. Example, for each of the following linear relations state the slope, the y-intercept, determine whether it does or does not represent a direct variation, justify that answer, and then determine the equation of the relation if it's a direct variation. If I look at the line, right off the bat, I see my y-intercept right there is 0. So I could say b equals 0 because b represents the y-intercept, or I can write it as an ordered pair 0, 0. M is the slope. If I look at this, to go from any point, I usually pick the origin if it's there because it's a nice point to read. I go up and over to find another line. And in this scenario, I went up 4 and left 2. Up indicates the y values are increasing, so it's positive. Left indicates the x values are decreasing, so it's negative. And the rise over run is positive 4 divided by negative 2, which tells me the slope is negative 2. And since this line has a negative correlation, and it indicates it's a decreasing relationship, it makes sense that the slope should also be negative. Now the equation of the line is y equals mx, so it just becomes y equals negative 2x. And this equation does represent a direct variation because it's a straight line whose y-intercept is 0. Next example. Pause the video and try and answer all these questions yourself before you listen. Again, we can look and see the y-intercept is 0. And we can go right 3, which is increasing our x's, and up 1. Notice the change in the scale here. We went 0.5, 1, 1.5, 2. We didn't number every box, or we don't have to, but we did see that 4 boxes had a value of 2, and if we split that 2 into 4, each box is worth 0.5. So we needed to be aware that even though we went up 2 boxes, that the rise is only positive 1. So the slope in this situation is rise over run, which is 1 over 3. And the equation, it is a direct variation because it's a straight line that passes through the origin. And the equation of the line will be y equals mx, which is y equals 1/3 x. Again, for the last example, pause the video and try and figure out the answers yourself. Y-intercept, oops, need to get color. The y-intercept is right there. That is not the origin. The y-intercept is 2, or the ordered pair 0, 2. The slope still gets found the same way though, because we're looking for the change in the y compared to the change in the x. I'm going right 3, so that's an increase, and up 2, which is also an increase. So my slope is 2 over 3. And it's not a direct variation because even though it's a straight line, it does not pass through the origin or through